Hello, my dear viewers. Welcome to PCM Guru Bro channel. This is the second part of the video which I have done on the physics class 12, the chapter regarding charges, um, electric charges. In the second part, we are going to discuss the last part which I have made you understand now, the quantization of charges and their properties. In that quantization, two problems I will do, and then the Coulombs Law I will introduce and do problems regarding two problems regarding that, or three problems regarding that. One is a theoretical level problem, and the other two numerical. This is a dimension based problem. Hey, yeah, the thing is, even if I am doing the best content for educational YouTube channel, I need a full support from your side. So please be with me. Please like, share, subscribe my channel. Let it be the gossip concept of between you all. Let the topics which I am teaching let it be the gossip subject, so that altogether I will get the profit, because if you score good marks, I will be profited, because what all I have taught you, you have got that best idea from what all is to study, and you scored good marks. That will be my asset. So be with me. Let's start. The point here is, first question is asked, a metallic wire has a 48 into 10 raised to minus 19 coulomb of negative charge. How many positive charges are in excess or short? That means a metallic wire, it is charged of 48 into 10 raised to minus 19 coulomb. How many positive charges are in excess or in short? Okay, how many positive charges are there? But here, we want to first of all understand this is 10 raised to minus 19 coulomb. Oh, it is the range of a basic electronic charge. Now, somewhat how much times it is greater? It is somewhat 1.6 into then 30 times, then it is greater. 30 times of an electronic basic charge. Okay. If the question is asked, how many positive charges are in excess or short? Okay, how many positive charges means? The negative means shortage of positive charge. You know that, no? So the question, how many positive charge, is it excess? No. If this is negatively charged, no, it is given in the question. Metallic wire, 48 in 10 raised to minus 19 coulomb, negative charge. So that means there is a shortage of positive charges. It is sure. So how many shortage of positive charges is what is to be found out. So the question is, Q is equal to Ne, the basic equation. From here, how much electrons are to be shorted out? That means N is equal to Q by E. The Q charge of a wire is taken Q, and E is the basic electronic charge. 10 raised to minus 19 is cut off. 48 by 1.6 is 30. So shortage of 30 positive charges are there in this metallic wire. That's enough. And question number 2 is, if Q is the positive charge on each molecule of water. Each molecule of water is what? H2O molecule. Each positive charge is regarding with each molecule of water. So Q is the positive charge on each molecule of water. So a molecular mass of water, okay, what is the total positive charge in a mug of water containing 360 gram of water? Okay, let a molecule of water have a Q charge, if it is to be found out. And you have a mug that contains 360 gram, nearly half a kilogram, 360 gram of water you have. Okay, it is calibrated value, so that you can understand the whole concept. That is why they have given a calibrated answer, 360 gram. Nearly half a kilogram of water is given to you in a mug, and then Q is the positive charge on each molecule of water. Okay, then what is the total positive charge in this mug? You want to calculate. Numerically, you want to calculate. Then first of all, the basic idea of the molecular mass of water, you know that, no? So 2 is with respect to hydrogen 2, and oxygen is 16 gram. So total molecular mass of the water is 18 gram per mole. So in each mole now there is 18 gram. Then we want to find out in one mole 18 gram molecule, then it has Avogadro number of molecules inside, no? Avogadro number of particles. Just name it molecules also. This much particles inside. That means 1 mole water contains 6.023 into 10 raised to 23 molecules. That means each corresponds to Q charge. Okay. This much molecules corresponds to Q charge each. But 360 gram of water, how much mole is it? 360 gram divided by this. 1 mole is 18 gram. Then 360 gram contains 20 moles. Now, that 20 moles contain, each mole contains 6.023 into 10 raised to 23. Then 20 moles contain 20 moles into 6.023 into 10 raised to 23 Q charges. Okay, that is Q Coulomb, which I have written over here. So the total molecules in 20 gram is equal to 20 moles into 6.023 into 10 raised to 23 Q coulombs. Because given each molecule has a Q Coulomb charge, in the question itself. That's it. So next comes the Coulombs law. Coulombs law, what is the basic law inside this charged particles? That means if it is a positive or a negative charge, is in at a distance placed at r. R is the distance between another charge. Two charges are there which are placed at a distance r between them. If it can be a positive charge, the other can be positive. It can be positive, other can be negative. This can be positive, this can be negative, and both can be also negative. So either positive or a negative charge, they are placed between a distance, they are placed at a distance r. Then what will be the force of attraction or repulsion between them can be found out by this Coulomb's law. So first of all, they have found out that the force is proportional to what the product of the charges. Okay, it's proportional to Q and Q2. This force is proportional to inverse of the distance between them. Hey, this is somewhat similarizing a gravitational law, no? So that's it. But we want to equalize this proportion. We want to make this proportionality sign into equal, no? So first basic equation: air or vacuum, no? There is a constant here, 1 by 4 pi, 3.14 something. Epsilon 0 is a thing called permittivity. What is permittivity? The thing is, no, we must the medium between these two, no, these two charges are in between. There is air, vacuum, or plastic can also be, plastic sheets can also be inserted. There can be air also. It can be also vacuum also. So air resistance and vacuum resistance are nearly same of these forces when it is placed in between. So this is corresponding to the value, the permittivity value of a vacuum here. So epsilon 0 is the permittivity of a free space. That means there is nothing like plastic or stone between this. There is only free space between these two. Then put the value epsilon 0. Okay. So what is permittivity? It can be said that is the measure of degree to which a medium can resist the moment of charge. That means, no, the charge when it is moved, no, it can freely and it can get free movement when it is in air and vacuum. But something different thing is placed over it, no, that difficulty increases. That difficulty increase is the measure of degree to which the medium can resist the movement of these charges. Okay, that's the permittivity. So a permit value, a permit which is given by vacuum, a permit which is given by air, and any core substance is placed inside, that permit is minimized. Okay, so that minimization of permit is calibrated to a value like this. This is the thing, which is to, if it is vacuum, we can place epsilon 0, no? But if another thing comes, something of a medium, which is so medium, no, then that if it is there, then we can incorporate a value like epsilon 0 into epsilon r. That means which can, there is a medium when it is placed now, then the multiple of this permittivity of free space we will make. So epsilon is the value when it is made to a quantity which is based on a material which is placed in between. So if air, no, there comes epsilon 0, then when it is placed in a relative medium, no, this thing, no, which will be this thing, which will be replaced by this. Understand? Okay. So this will be replaced by this. That means epsilon 0 will be replaced by epsilon 0 epsilon r. That means epsilon will be placed over here. That is the relative permittivity. Okay. By the problems which we practice now, after that I will tell you clear. I will make it is not that difficult here. Just understand there is a constant which is used as when it is in free space. If any other coarse substance comes in between these two, then this is replaced by a value. That is called a dielectric constant. So that will reduce, that is in the denominator position, no? That will reduce the force. Okay. If it is that when it is placed over here will reduce the force. The whole quantity will be reduced by what is. So if it is in free space, no, this is having a value of 1. Okay. Then when it is placed in other medium, it is greater. If plastic, no, it is greater than 1. That means force will get reduced in between these two charges. Okay, by now you understood, no? So this ratio of a medium by the free space, no, it is called dielectric constant, which is written by epsilon r. Epsilon r. It is also written as K. That is a force in the medium is much less than force in the vacuum. Okay. That is dielectric constant is it is something which will make this dielectric constant is a value which is a relative value between that medium permittivity and the permittivity of the free space. That is written in a sentence here. Permittivity of the medium by permittivity of a free space is dielectric constant, epsilon by epsilon 0. And relative permittivity, it is also a relative permittivity. That means related to medium and vacuum. That's it. And epsilon 0, try to know this value, 8.854 into 10 raised to minus 12 Coulomb square plus Coulomb square by Newton meter square. That's the thing. Just know this basic law in free space or air, 1 by 4 pi epsilon 0 Q1 Q2 by r square. When in the case of a medium is introduced, no, just we will apply this 4 pi epsilon. Epsilon 0 is replaced by this epsilon, where we will multiply the basic quantity, no, K1 into that value of that relative permittivity value. So that will be greater than 1. Okay, plastic value. By following a problem, you will get clear. At that time, I will tell how to apply all this. Just understand the force between two charges is 1 by 4 pi epsilon 0 Q1 Q2 by r square in free space. That's it. So obtain the board examination question. First board examination question comes. That's in free space. Okay, that's in free space. No plastic is introduced. Okay, this is a problem in free space. So obtain the dimension formula for 1 by 4 pi epsilon 0 of Coulomb's equation. Here I missed something, that is 1 by 4 pi epsilon 0. No, this is having a value 9 into 10 raised to 9 value. Remember also that. Likewise, we have earlier in the plus 1, we have remembered this G value, 6.67 10 raised to minus 11 Newton meter square per kilogram square. Likewise, 1 by 4 pi epsilon 0 value is 9 into 10 raised to 9 value. Okay, coming to the question. Force is equal to 1 by 4 pi epsilon 0 into Q1 Q2 by r square. That's the question which is asked. And obtain the dimension formula for 1 by 4 pi epsilon 0 of Coulomb's equation. This is the Coulomb's equation. We want to find out the dimension formula, MLT like form now. So just take this 1 by 4 pi epsilon 0, let it be here, and take this r square over here. Divided by r square will become f into r square. Okay. That is here. And this 1 by 4 pi epsilon 0 into Q1 Q2 will become divided by Q1 Q2. That's the equation. This equation will be transformed into this form. 1 by 4 pi epsilon 0 is isolated to one side, and f r square by Q1 Q2 is taken over here. F, force. That means mass into acceleration. That means acceleration means L by T means velocity. L by T square means acceleration. So LT raised to minus 2 is acceleration. mass into acceleration, that is force. R square is in length, so R square means L square. Any length, the length between these two, so L square. Q1, Q2, that means the charge you have earlierly in the first part. I have made you M0, L0, T raised to 1, A raised to 1 now. So Q1, this T1, Q2, this T1, A1. Okay. So these two when multiplied you get T square A square now. And here when you see M, it is placed like that. L into L square, L cube, T raised to minus 2. Okay, it is written. Here now, T raised to minus 2 in the bottom will, when it get to the numerator, then it will get T raised to minus 2. Then T raised to minus 2 into T raised to minus 2, T raised to minus 4. M L cube, T raised to minus 4. And A square when it get to the numerator, A raised to minus 2. So M L cube, T raised to minus 4, A raised to minus 2 is the dimensional formula of 1 by 4 pi epsilon, 1 by 4 pi epsilon 0, this thing. Okay. That's a constant, proportionality constant of Coulomb's equation. And write the Coulomb's force between a proton and an electron separated by a distance r. Okay, proton, first of all, for writing that equation, we must name before so that our examination sir will be making him understood, convincing him. Let Q be the charges of proton and electron. Okay, let's think. Then Q into Q, that is Q square. By this formula, Q be the charge, Q1 and Q, same charges. So Q for the Q1 for Q, Q2, Q. So these two are same. Then Q into Q means Q square. Then the distance between them is R square. Same formula. The force, Coulombic force between a proton and an electron when the charge is taken to be Q for the proton and electron, then 1 by 4 pi epsilon 0 and Q square by R square is the force between them. Then mass of proton is given, mass of electron is given, charge of electron is given, gravitation constant is given. Universal gravitation constant is given. Determine the ratio of electrical force to gravitation force. You want to find out. Then just to find Coulombic force we know now. So 1 by 4 pi epsilon 0. What is the electronic charge? That is E. Just name it, charge. E into E. That means Q1, Q2. E into E. That is E into E by R square, distance between them. Okay. And then divided by Fg by G M1 M2 by R square. M1 means mass of proton, M is mass of electron by R square. These R and R get, okay. In the next step now, A by B divided by C by D is equal to A by B into D by C. That property I will apply. Fc by Fg, same written. 1 by 5 pi epsilon 0 E by square by R square written over here into R square by G into MP ME. Okay. That I am brushing up your fundamentals. The thing is A by B divided by C by D is equal to A by B into D by C. That's the thing. So is equal to 9 into 10 raised to 9 is the value of this, which I have taught you. 1 by 5 pi epsilon 0. And E square, E value is 1.6 into 10 raised to minus 19. That is squared divided by this R square get cancelled out. The 1 will remain. That 1 into this here also 1 will remain, divided by G value 6.67 10 raised to minus 11. 1.67 is the mass of the proton value, MP, and Me is the mass of electron, 9.1 mass of electron. And just we will sort out to accumulate in one area, that 9 into 1.6 square. Okay. And 6.67 into 1.67 into 9.1. Let it all be there. You when calculate, we will get 2.3 value. Here now, 10 raised to 9 into 10 raised to minus 38 divided by 10 raised to 9 into 10 raised to here, minus 19 into 2, minus 38. And divided by 10 raised to minus 11, 10 raised into 10 raised to minus 27, 10 raised to minus 31, written over here. Okay. This whole thing, when by the theory of indices now, 9 minus 38 plus 11 plus 27 plus 31. Okay, 10 raised. This is the solving procedure. Look here, 38, minus 38 plus 31 minus 7. Minus 7 plus 27, 20 plus 20 plus 20 plus 9, 29. 29 plus 11, 29 29, okay, once again, sorry. 38 minus 31, 7. 7 minus 27, 20. 20 plus 1, 20, 31, 30. Anyhow, okay, this is the thing. 39 value. Just okay. Just understand. Uh, 7, 7, 7, 20, 20 plus 1, 21, 21 plus 7, 7, minus 7, minus 38 plus 31, minus 7. Minus 7 plus 27 plus 20 plus 20 plus 11, 20 plus 11, 30 plus 20, 20 plus 11. My dear friends, this answer is correct. The thing is that I have become full doubtful over here. And so that when we process this whole things, we will get this answer. That's the thing. So if any doubt arises, call me. That's it. And the third question is, because of the time constraint, it is becoming tension, full of tension for me. So the third question is, define SI unit of charge. That means define a Coulomb. That means 1 Coulomb is that amount of charge which repels an equal and a similar charge with a force of 9 to 10 raised to 9 Newton when placed in vacuum at a distance of 1 meter from it. What is that? Defining a Coulomb. What is that? Defining a Coulomb. That means a Coulomb, when is the Coulomb is that charge. That means define the SI unit of charge. That means 1 Coulomb we want to understand. So Coulomb is that amount of charge which repels an equal amount of similar charge. That means Coulomb is that charge which repels an equal amount of other charge. Okay, an equal amount. This equal amount of charge, similar charge with a force of 9 into 10 raised to 9 Newton. This will become 9 into 10 raised to 9 Newton when placed in a vacuum at a distance of 1 meter from it. I will simplify it to you. That means if it is taken to the other side, these all things, it will become like this now. So Coulomb is that force. This Coulomb is that force which repels an equal and similar charge with a force of 9 into 10 raised to 9 Newton. This 9 into 10 raised to 9 Newton when placed in a vacuum at a distance of 1 meter from each other. Okay. So again, study this by heart, try to by heart this thing. Defining SI unit of charge, that means Coulomb. 1 Coulomb is that amount of charge which repels an equal and similar charge with a force of 9 to 10 raised to 9 Newton when placed in a vacuum at a distance of 1 meter from it. So guys, please note all these problems well, study. If you have any doubt, call me. Please like, share and subscribe my channel. I'll be there for you. There is no doubt in all the answers which I am giving you. So just practice and be perfect. That's it. Be happy, be cool. Yeah. Bye. See you in the next video.